So today's assignment, folks, is right here, doing the opposite from last time. So right now we're going logic expressions to truth tables. So the assignment, if you scroll down, it says starts on page 4, and so it's going to start here. So it's 1, 2, 3, right here, these three right here. And this is just a PowerPoint. And the only reason I put this PowerPoint in here is it's for your notes, but mainly it's to know how to build a 2-input, a 3-input, or uh, a 4-input truth table. So a 2, a 3, or a 4. I'm going to show you really quick how to do that. And it's a nice, easy pattern. So watch this. So first off, a blank one. So if you had a 2 input, so let me give you an example. What if they gave me an equation like this? So F1 is equal to not AB, or let's say AB. So if they gave me this, I only see two different letters. I see A's and B's. That's all I see. So we're going to assume that this thing only had 2 inputs since there's no other inputs anywhere it's talking about. So we're going to say that this is a 2 input. And when you do that, you're going to have an A input and a B input. And of course, we're going to have the 1 output. And you only need, I think it's 4 different lines. And the reason being is the only patterns possible are they both off, this one's on, or only this one's on, or they're both on. That's the only combination. So it's really easy to do. And there's actually a pattern, by the way. Look at this row, 0, 1, 0, 1. Look at this row, 0, 0, 1, 1. So there's kind of a pattern here. Right here, now we got to fill this out. Now we have to look up here. And we're going to put a 1 for every one of these minterms. So we need to find one where A is off and B is on. A is off and B is on. Here we go, right here. So the machine is on here because A is off, 0, and B is on, 1. We also need to do it where they're both on, A and B. See, there's no knots on top, so they're both on, and that'd be this one, on. Here we go. Fill the rest with zeros, and we're done. That's a simple one, real easy to do. Now, what if there was 3 different terms? So let's go with, let's say this one's F2, and it's equal to, I'm going to do different letters, X, Y, Z, and we'll say not here, or to make this easier for myself, I'm not going to make a super long equation either, because that's just more things I have to find. But I am going to show you one other one here. Let's go with X, Y, Z, and they're both off here, but the middle one is on. And I'm going to do this little trick here. Watch this one. Y, Z. I'm just going to put Y, Z. Notice there's no X here. Don't worry about that right now. We'll talk about that in a minute. That means there's going to be more than one possibility for this one, and you'll see in a second. So notice that there's 3 different ones, X, Y's, and Z's. That's all there is. There's 3 terms. So this is going to be a 3 input, which means it's going to be twice as long as this. So instead of 4 long, it's going to be 8 long. And we're going to have 3 terms, X, Y, Z, and don't forget about the output F2. And what does it look like here? Let's put a line, let's put a line, let's put a line, and a line. And here we go. This first one on the far right, I say on the first one over here on the right side, look at the pattern. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Should be 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I did too much extra. There we go. 8 terms. Now over here, it's 2 zeros. And by the way, we should try to put some lines this way so they line up. Let's do that now before we forget. There we go. 2 zeros, 2 ones, 2 zeros, 2 ones. That's all there is to it. This last one, it's 4 zeros. Look at the pattern. 1, 0, 1, 1, a 0, 1, a 0, 1, a 0, 1. 2 zeros, 2 ones, 2 zeros, 2 ones. This one, 4 zeros and 4 ones. And we're done. This is every possible combination. By the way, if you're counting in binary, this is number 0, then 1, then 2, 3, 4, 5, 6, and 7. That's 8 different numbers. Just for educational purposes, this is 0 through 7 in binary, which is every combination possible. Now, Let's find one where X and Y are on, but Z is off. That would be this one right here. X is on, Y is on, but Z is off. That's that one. Let's go here. X and Z are off, but Y is on. That's this one right here. So this one's off, but this one's on. Now the last one. Here's a little tricky. There's only two terms. I need to find when Y and Z are both on. Here. But here as well. Now here's the thing. These are both on, right? Y and Z. See, here's Y, here's Z. Y and Z are both on, so that is true. Here, Y and Z are both on, so it's also true. You might say, well, what about X? It doesn't really matter what X is doing right here, whether it's off or it's on. It doesn't really matter because they didn't mention X at all. So because they didn't mention X, it doesn't matter. So the rest of these are going to be zeros. So we're going to fill zeros here, right here. There we go. So any questions thus far? So the last possible combination then is going to be a what, a 4 one. So let's go to new, and oops, it's asking me if I want to save it. So let me come up with one with 4. So let's call this F3, and let's go with A, B, C, D. So we know there's 4 different ones, or A, B, C, and let's put them all off. All right. So here's another one where we have 4 terms. We have 4 terms, and but this one only has 3. So we definitely know there's 4 things going on. So it's definitely going to be a 4 input, which means we're going to have an A, a B, a C, and a D, and an F3. What? Sure, if you want to go, we'll go camping. How about that?
With this?
With those.
Yeah.
So, now how does the pattern look here? Same start. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. But there should be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I need 2 more. Just enough room here. 0, 1. So let's continue these lines down. And then this next row, I need to start creating this like little line here, so otherwise you can't tell what lines up with what, you know? So I'm just gonna kind of shoot a line through here. Sorry that they're not perfectly straight. This is on a computer and I don't have rulers on the computer. So let's just go through, see if I can do this without making it look too dumb. Is that all of them? Oh, there's one more. So the next row is 2 zeros and 2 ones. So 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. And that's it. That's all of them. The next one is 4 zeros and 4 ones. 1, 2, 3, 4. 1, 2, 3, 4, and then 4 zeros. 1, 2, 3, 4, and 4 ones. 1, 2, 3, 4. That's all done. And this last row, you may be guessing that it's going to be 8 zeros. Notice it just keeps doubling. 1, 2, 3, 4, 5, 6, 7, 8, and 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Done. That's every possible combination. Sorry, it's kind of ugly. And then now we have to write the functions every time this machine's on. Now, if this was a longer equation, there'd be a lot more ones over here. But this one's just 2. I try to make it really easy, so I'm not going too long here. A, B, C, D, but only the A and the C are off. There's only going to be one of those. A and the C are off. Right here, I think I found it. See, C is off and A is off, but the B and D are on. Let's just double check. Yep, the B and D are on, A and C is off. That's it right there. This one, there's I need to find when A, B, and C are all off. What about D? Question mark. What do we do with D? D. There is no D here, which means we don't care. So D could be off, it could be on, it doesn't matter, as long as these three are off. That brings us to this one and this one. See, A, B, and C are all off. D, I don't care. A, B, and C are all off. This one's on, but I don't care because it doesn't mention D at all. It just says if A, B, and C are all off. And in these two scenarios, as you can see here, they are, right? Now, there is no other scenario. You can look around on this chart. There's going to be no other ones. So at this point, we could just fill in the rest with zeros. And we're done with this truth table. And that's all there is to today's assignment.